Hi class, my name's Steve Shota, and I wanted to go ahead and give you a review on chapters 1 through 3. I appreciate your flexibility and us not being able to meet this week, but I thought just dropping this video in may help out. So let's go ahead and get started. Wanted to begin with chapter 1, and really starts out right away with the definition of statistics. And it's a bridge between the physical and the metaphysical, as I was talking about in our first lecture. We've got a lot of variables in our world, both scientific, social science, business, manufacturing, in all facets of our lives. We've got things that we want to measure and express. And those expressions can either be qualitative or quantitative in nature. We like to talk about qualitative data as categorical data, and quantitative data can be either discrete or continuous. So what we do with the data is there's several purposes like we discussed, and one important one is to make predictions. Another one is to control processes. Another is to solve problems. So there's one of the real powerful things about statistics as we get into more advanced discussions is going to be the ability to detect patterns. So keep these things in mind. And the other thing, kind of just to repeat that, even though big words, physical and metaphysical, the metaphysical are all the theories, all the definitions, the concepts, all the things that we employ in order to get a mental picture of our true physical state of nature. So what we're often doing in statistics is getting a sample out of a population and then using that sample to estimate the true measures, metrics associated, or parameters, right? We learned the word parameters. This is associated with population. So the true mean is the parameter of the population, and it's estimated by the sample statistic called the average. So that's the protocol that we want to use, and we have to keep our language very succinct and accurate as we're going through these various topics. So again, the mathematics and statistics is pretty simple. That's nothing more than in our course than general algebra, but the concepts are the real stickers. So that's where we've got to be memorizing and making sure that we have a complete understanding of these various descriptions, so that we can accurately convey to others the observations that we're making about data. So it gives us a common platform from which to share information, and that's another good benefit of statistics. So also in chapter 1, we spent we kind of got the definition of a variable on page 8, and then we went through a lot of different graphs for displaying quantitative information. So kind of started out with the real basic pie charts and bar charts, and then we moved into more useful charting for detecting trends and actually seeing what kind of patterns we might be able to associate with data, with line charts and dot plots and stem and leaf plots. And then we're getting into some of our the basic first principles of really seeing how to describe our physical world in statistics through the relative frequency histogram. So these are all very important to thoroughly understand as we're at this initial point in our class. So just another point is these are the most useful. And what what audiences of prefer to see are not very complex presentations of statistical knowledge, but what they want to see is that the analysis work has been done, that they want to see the output of it. And they want to see it in as simple format as possible, so that that simplicity does help make sure there is not confusion. So a lot of times bar charts and bar charts and pie charts are very frequently the types of charting that you'll see in high management reporting. Again, they want to focus on strategic matters and qualitative matters and understand, and they do look at some quantitative things, but they don't want to be distracted with a lot of analysis. They want to look at derived data and what does the data tell us. So that's, even though it may seem that they're being elementary, they're really just wanting to stay elementary so that they don't have to spend a lot of time thinking about complex things which could mire them down in the real directions that they're trying to run with their organizations. So when we move into chapter 2, that's descriptive statistics. And on page 53, we talk about the measures of center. And I think everyone's pretty familiar with the mean, the mode, and the median. Page 60, we get into the measures of variability. And this is the range is the most basic, and then we'll get into the standard deviation and the variance. So those are the most frequent. Also, on page 66, we have Chebyshev's theorem, and page 67, we have the empirical rule. I'm most accustomed to using the empirical rule, and that one is 68, 95, and 99.7. And if you look, they introduce kind of quietly on page 67 the normal distribution. So that is going to be something we spend, a large content of our class talking about. It's the normal distribution. And when you look at the normal distribution, what the empirical rule is telling us is that 68% of the data falls within plus or minus 1 standard deviation unit of the average. 95% of the data values are going to fall between plus or minus 2 standard deviation units, and 99.73% of all data is going to fall within plus or minus 3 standard deviation units. So the empirical rule is probably the more common application, because you can just remember 68, 95, 99.7 as Chebyshev's theorem as a formula. So most people don't recall these kind of formulas, but it's just as useful. And what is the purpose of it? We didn't really cover that in class, but the purpose is to use that as a gross error check if you've done a standard deviation calculation. So you can kind of, use those rules of thumb of the Chebyshev's theorem and then the empirical rule to really see, does this standard deviation make sense once you've calculated that value, that statistic, off of a set of data. So, and then the section we needed to spend some time on, and I encourage you to look at this in the book on page 75. And I really like the way that the author did this. Is he calls the z value, the z-score, that is, I've heard it z-value, as a measure of relative standing. So I thought it's really a good way to make that distinction, because what that is a measure of in the descriptive statistics of your data is a position of where is my value that I'm interested in relative to the other, to the mean, and in terms of the standard deviation of that data. So any kind of data that you sample, or any population you sample, and you have that set of data, the average and the standard deviation is really what is used to describe that data. Now you can also plot it and then see what kind of shape that data has. But the X bar and S are your go-to data that you need, or the go-to statistical values that you need to really be able to assess any sample statistically. So, and then essentially, right, you got a data value, you know the center of it with X bar, and you know the standard deviation, then you can get the z-score. So that gives you that position, that relative standing. I like that, with where that data point falls within all of the data. Just a point I think the book even shares is that if it's a positive, it's going to be on the right-hand side of the average, and if the z-score is negative, it's on the left-hand side. So it gives you the direction from the average as to where that z-score is. And it's similar. We've all probably had this in prior courses, and we know it in many media reports, newspapers, where they use percentiles. We see a common use on this percentiles are the SAT scores and things like that. So that percentile is another measure of relative standing, and then another kind of derivation of that is quartiles, which is like, well, which quartile are you in? That pretty much covers the descriptive statistics, other than on page 80 is the 5-number summary, which is kind of covered in the box plot. So I encourage you to look at that, because box plots are useful. They visually can show you the spread of the data in kind of a simple way, and if you can kind of look at those and you can see the spread of the data. You can see where those the quartiles are. So that kind of gives you a good clue as to if that data is if it's a normal distribution or not. This is the actual helpful thing out of the box plot. So that kind of covers our overview of chapter 2. The chapter 3 really goes into bivariate data. So up until this point, we've all been just discussing what to do with single variables. So all of the prior content we just talked about was fully applicable to a single variable. And when you add a second variable, and that's very frequently the case, you're gonna we kind of got our number line where that we've been looking at that single variable, and then if we add the second variable, we'll usually go vertically. And so it's really no different than seeing that single variable kind of expressed as it is plotted vertically, and then the other variable is plotted horizontally. So this approach is typically each point is an XY variable. So the X goes along the X values are plotted against the horizontal axis, and then the Y values are plotted on the vertical axis. One thing to keep in mind is the independent variables and dependent variables. So an independent variable is usually is put on the X axis, and the dependent variable is put on the Y axis. The most frequent independent variable, like we talked about in class, is the variable for time. So if you're going to measure temperature over time, you're going to put time on the X variable, on the X axis, the horizontal axis, and you're going to put the temperature on the Y vertical axis, and then that becomes a run chart. Actually, is a common term for that once we get into the control charting. So the reason bivariate data is important is there's often an interest between these two variables. It is interesting and of interest to figure out how temperature trends over time, right? In fact, we've gotten very sophisticated in our weather data reporting, where we're making predictions, and And with satellite communication now, and satellites taking meteorological data continually, I can't imagine the billions of data points that are processed daily related to weather. We now have a pretty good idea what the next 3 days are really going to look like, and we really have a solid idea of what the next 24 hours is going to look like. The weather prediction accuracy and precision is really pretty high these days, and it's all because of the technology that we've been able to get up into using satellites. So I guess, look, when you look at chapter 3, we're really looking at, this chapter covers the first principles at looking at relationships and how we want to look at relationships between bivariate data, so relationships between two variables. That convention's in X's and Y's, and the first one is on page 102, the scatter plot. So that's really the basic thing, and that's really, do you see a trend between does Y increase as X increases, or does Y decrease as X increases, or is there any pattern whatsoever? So that scatter plot is your first visual display of that graph of that data in order for you to observe where do these data values plot out so that you can have a good idea of where they're at. So just kind of fast forward there, page 105 is the correlation coefficient. There is an equation for that. You can see it's R equals S of XY divided by the S of X times S of Y. So essentially, figure out the standard deviation of the X values, you figure out the standard deviation of the Y values. The product of those is then becomes the denominator, but then this value called the SXY is called the covariance, and you sum up all the variation between each data point and make an expression out of that, and that covariance takes over the numerator. Fortunately, we have Minitab, so that calculation would be very tedious without a computer, and particularly without Minitab, because even if you have a calculator, you're going to have a lot of key presses there to do in order to try to calculate that. So we're fortunate that we don't have to focus on the arithmetic at all with the computer application that we've got. Page 108 kind of repeats kind of formally talks to you about the dependent, independent variables we were talking about. And then on page 109, we have the least squares regression line. So that is a best fitting line that takes the minimum between the data points and a line that would fit best across the data. So, and then that kind of gives us a relationship strength to see if that's where we get the correlation coefficient as well, and we can see how we'll put that best fitting line and the correlation coefficient. We can use those to really assess what kind of relationship we have, because our relationship is going to be measured in its form, which is the shape of the data and how it plots out, and then we've got direction, so that we can see, is it increasing or decreasing between as one of the variable varies. And then the third relationship factor that we're looking at is that strength of the fit between those two variables. And if we have a correlation coefficient of 0.7 or greater, we have a strong, that's plus or minus, a strong relationship. If it's 0.3 to 0.7 plus or minus, then that's a moderate relationship. But if it's less than plus or minus 0.3, then it's a weak relationship between the values. And just one important point, which I'm sure, I think I got a pretty solid head nods when we were in class, is that correlation does not mean causation, and there's other tests for that. So that's the review of our chapters 1 through 3. I did get the assignment posted on Blackboard, so if you could scan your results. If you can use the snip function, I think if you use Minitab and you snip the output, or if you want to save that file, you can upload that too. I can look at it using Minitab. But I prefer if you just took everything and kind of snipped it into a Word document or scanned it, whatever format you want to use. I did come up with a grading scheme a little bit, so the homework assignment, I put a value of 20 on it. I did give you a couple bonus questions there, and then next week we'll actually start with some quizzes. So we'll have a quiz over chapters 1 to 3, and then later on in another day or so, I'm going to post a presentation on chapter 4 and chapter 5, so that we can begin that material. So again, use email if you got any questions, and hope you stay warm. This weather forecast for tomorrow is pretty brisk. So thank you.